In this video, I want to talk a bit about the importance of being certain that you're focused on the correct area under the curve so that you don't accidentally report the wrong answer when using z-scores or other similar measures that we'll learn later. I mean, look, I don't want to insult anyone's intelligence here, but sometimes I see students who seem to understand the material, but for one reason or another, they end up reporting the wrong answer because they're looking at the wrong area under the curve. I mean, ouch! I mean, it kills me when that happens. So let's spend a few minutes talking about what I refer to as the magic words. Now, what do I mean by magic words? Well, I mean the words that in a research question tell you exactly what part of the normal curve you need to look at. For example, a question may ask about the proportion of people above a given score or greater than a given score or more than a given score. All of those involve focusing on the area from that score to positive infinity in the upper tail. It doesn't matter what the score is, whether it's a big positive z-score or a small positive z-score or even a negative z-score. Questions of above, greater than, more than are asking about the area from the z-score to positive infinity in the upper tail. This blue area right here. Now, again, whether it's all of that blue area for a z of -2, or all of that blue area if it's a z of positive 0.2, or just that area for a z of positive 2. The area is equal to the proportion of people, or whatever you're studying, maybe rhinos or grasshoppers, that are above, greater than, more than that z-score, all right? On the other hand, what if a question asks about the proportion of people with a result that's below a given score or smaller than a given score or less than a given score? All of those questions involve focusing on the area from that score down to negative infinity in the lower tail. And again, it doesn't matter what the score is, whether it's a big negative z-score or a small negative z-score or even a positive z-score. Questions of below, smaller than, less than are all asking about the area from the score to negative infinity in the lower tail, this blue area here. And again, whether it's all of that blue area for a z of positive 2 or all of that blue area if it's the area below a z of -0.2 or just this area if it's a z of -2. The area is equal to the proportion of people, rhinos, grasshoppers that are below or smaller than or less than that z-score. Now, the next one's a little more subtle, and it really comes down to recognizing exactly what the question's getting at. For us, the keyword, the magic words, are more extreme. For our class, for me, when we talk about anything being more extreme than a given score, we're talking about both tails, okay? You're interested in the area that's beyond the plus and minus values of whatever score you're interested in, right? The area from the positive value of your z-score up to positive infinity, plus the area from the negative value of your z-score down to negative infinity. You want both areas, both proportions under the curve, because they're both equally extreme, just in opposite directions. Now, outside of class, one can debate whether more extreme can apply to just one direction. I mean, of course it can. And you have to be extra careful in the real world when you're reading studies or doing analyses to be certain that everyone means 2 tails. But in my class, we'll keep it simple and straightforward. When I say more extreme, I mean the area from that z-score to infinity in both of the tails. Right? Now, keep in mind, I'm doing this as a favor to you, my students, to help make it clear. Now, I've made this distinction for a while now, and I still occasionally get a student who comes back and argues that extreme can mean just 1 tail. And I'm like, you weren't in class on that day, were you? Or guess who didn't watch the video? But now you'll never make that mistake because you know the magic word, right? Now, the final magic words typically apply to a different type of situation that we'll see more often later on. But let's introduce the idea and the magic words now. And that's when we talk about something being less extreme than, or bounded by the plus and minus values of some score. In this case, we're interested in the area between the plus and minus values of some score. As we'll see later, this type of question is often approached in a different sort of way. Instead of what's the proportion above or below a z-score, these questions often involve determining what score bounds a given percentage of the normal curve. For example, 95.4% of the cases are between a z-score of -2 and a z-score of +2. Z-scores of plus and minus 2 bound 95.4% of the distribution. And 68.3% of the cases are between a z-score of plus and minus 1. Z-scores of +1 and -1 bound 68.3% of the distribution. In the end, the key is to first determine which of these different scenarios reflect your specific research question. And then be certain that when you're looking at the normal curve, or some other distributions that we'll see later, you're actually finding and reporting the correct area for that question. This general concept of using the area under a curve as a way of determining the proportion of cases above or below or more or less extreme than some value is something we're going to use a lot in statistics. Don't just find a number and say, there I go. Be certain that it's the right value that reflects the right area for the right question. Just think of the video with the goofy professor and the funny hat. Goofy, you can't see my Mickey Mouse ears. Think of this video and you'll be okay. All right? Take care. Bye-bye.